Okay. It's an introduction. All right. Hey guys, we're on our 1.3 intro to piecewise defined functions. This is the last part of this unit. 1.2 and 1.3 is combined. They are both very tiny units. They're literally about applying average rate of change and using piecewise functions. That is it. That is the unit. Okay. It is a 1 week unit. That's why we test on next Tuesday. If you read your agenda page, we test after our break on Monday. Okay. So I'm going to play this little introduction video of the soothing voice of Dr. Khan. As I said, please don't insult Dr. Khan. Okay. So we're going to watch 3 minutes. I want you to do nothing but listen and watch. No devices should be out. You shouldn't be working on any problems. You shouldn't be on your phones. You shouldn't be listening to music. You should just be listening to the soothing sounds of Dr. Khan.
By now, we're used to seeing functions defined like h of y is equal to y squared, or f of x is equal to the square root of x. But what we're now going to explore is functions that are defined piece by piece over different intervals. And functions like this you'll sometimes view them as a piecewise, or these types of function definitions, they might be called a piecewise function definition. And so let's take a look at this graph right over here. This graph, you can see that the function is constant over this interval for x, and then it jumps up to in this interval for x, and then it jumps back down for this interval for x. So let's think about how we would write this using our function notation. So if we say that this right over here is the x-axis, and if this is the y is equal to f of x axis, then let's see, our function f of x is going to be equal to, let's see, there's 3 different intervals. So let me give myself some space for the 3 different intervals. Now this first interval is from not including -9. I have this open circle here, not a closed-in circle. So not including -9, but x being greater than -9 and all the way up to and including -5. So I could write that as -9 is less than x, less than or equal to -5. That's this interval. And what is the value of the function over this interval? Well, we see the value of the function is -9. It's a constant -9 over that interval. It's a little confusing because the value of the function is actually also the value of the lower bound on this interval right over here. And it's very important to look at that this says -9 is less than x, not less than or equal. If it was less than or equal, then the function would have been defined at x equals -9, but it's not. We have an open circle right over there. But now let's look at the next interval. The next interval is from x is greater, or -5 is less than x, which is less than or equal to -1. And over that interval, the function is equal to, the function is a constant 6. It jumps up here. Sometimes people call this a step function. It steps up. It looks like stairs to some degree. Now it's very important here that at x equals -5, for it to be defined only one place. Here it's defined by this part. It's only defined over here. And so that's why it's important that this isn't a -5 is less than or equal to, because then if you put -5 into the function, this thing would be filled in, and then the function would be defined to both places, and that's not cool for a function. It wouldn't be a function anymore. So it's very important that that when you input -5 in here, you know which of these intervals you are in. You can't be in two of these intervals. If you are in 2 of these intervals, the interval should give you the same value so that the function maps from one input to the same output. Now let's keep going. We have this last interval where we're going from -1, we're going from -1 to 9, from -1 to +9, and x, it starts off with -1 less than x, because you have an open circle right over here, and that's good because x equals -1 is defined up here, all the way to x is less than or equal to 9. And over that interval, what is the value of our function? Well, you see the value of our function is a constant -7. A constant -7. And we're done. We have just constructed a piece-by-piece definition of this function. And actually, when you see this type of function notation, it becomes a lot clearer why function notation is useful even. And hopefully, well anyway, hopefully you enjoyed that. I always find these piecewise functions a lot of fun.
I always find your voice low. All right, so basically, introduction to piecewise functions. Do you all remember our Super Bowl problem yesterday? Yes, ma'am. Yes. Did we have had to write the headline. Oh, yeah. It was about the Super Bowl. Okay.
49.
We had 28 different intervals, didn't we? So that was a piecewise defined function. Each interval was doing its own thing, correct? Not one interval was on a same steady slope or anything. That's an example of piecewise, okay? Piecewise functions how our whole world really works. Nothing is perfectly linear. Nothing is perfectly quadratic. Nothing is perfectly exponential. When you drive out of a parking lot, do you hold down your gas pedal until 60 and then zoom out? No, you do not. And if you do, you should not have a license, okay? For a certain interval, huh?
I don't have one, ma'am.
Yeah,
That's why.
exactly why I did.
Okay, but that is why life is not perfectly any function. It is made up of pieces of function, which is where piecewise defined functions come into play. Okay? All right. So our dive in, our goals for our piecewise. Thing number one is, can we evaluate? Okay, can I evaluate? No, or can we? Oh, yes, you're gonna write this down. I said, wait, am I gonna write it down? No, you're gonna write this down. So your example one that you're writing down is on the board. But our goal number one is, can we evaluate? So I'm gonna give you 90 seconds to write down the function. Next, it's an image for you, exactly how it should be in your notes. Like, what else do you want me to do? You put your example one wherever you want. If you want it on the bottom, put it on the bottom. Okay?
The grid,
You have the grid. I gave you the grid.
but like the numbers on the grid.
Just put in the X and Y axis, guys.
Oh.
I was like, I gave you grid paper. Y'all are killing me. All right. So 90 seconds, write it down. So our function is f of x equals 2 minus x if x is greater than or equal to -3, but less than -2. Or 1 minus x squared if x is greater than or equal to -2, but less than or equal to 1. Okay? Or x to the third if x is greater than 1, but less than 3. Okay? I said I'm giving you 90 seconds. I was just reading what was on the board. All I did was, what do you mean all of that? It's not even that much to write. Yes, you need the numbers.
Damn.
I hope so. I hope they are, Mark. I hope so. If this is real life questions and problems. Oh, darn it.
Oh, lucky.
Oh, man.
I want to be in your schedule then.
I'm sad. I'm sorry for that lack of effort that you're getting throughout the day. Or you're choosing to not put in and being accepted.
I wrote it down.
You wrote it down. Good job. That's all we've done so far. Good job.
That was weird.
All right. Are you ready? I hear a lot of talking, so I think our 90 seconds can be sped up. He was trying to decide who's writing on the top or the bottom of his paper.
Oh, yeah.
I did have to decide that.
Are we gonna be doing? Doing the graph, are we gonna be doing that way, you're not gonna do it like this, or like down the middle, where I look at all the-
We're only between -3 and 3. Like our x-axis only goes -3 to 3.
Oh, this-
Yeah, you have plenty of room.
Don't stress it.
Yeah.
I'm just gonna.
We'll figure it out.
Whether to make my.
No, you're from -3. See where our first lower bound is?
Yeah.
Starts at -3, and then our biggest upper bound is 3. So we're only using x's between -3 and 3. Okay. All right, here we go. So everyone should have written this down. Right now, we're going to be evaluating, because if we can't evaluate, then we can't graph. Does that make sense? So we need to make sure we can evaluate. What makes evaluating piecewise functions unique is that you have to determine which interval does your value fall in order to know which piece of the function to use. Okay. So we have 1, 2, 3. Emiliano, can you open the door, please? Okay. So first thing we're going to evaluate is -3. So we're evaluating f of -3. Just leave it open. Someone knocked on it and then they walked away. So we're evaluating f of -3. First thing is I'm going to decide what interval does it fall on. So looking at my options, what interval does -3 fall on?
Oh, 1.
1. -3 falls on 1. It's right here. It says x is greater than or equal to -3. So that means I'm going to use this function to evaluate. So where x is, I'm plugging in a -3. So we have 2 minus -3. Okay. A negative times a negative makes a positive. So this is actually 2 plus 3. And what is 2 plus 3? 5. At this point, the hope is that some of this math can be done mentally. So no, I didn't anticipate you needing a lot of space. But if you need to write it out, I get it. But again, I did not anticipate you needing a lot of space. Okay. So the end goal is f of -3 is 5. Yes? We get it? And we know that because -3 falls on interval 1. Okay, next one. We're going to evaluate f of -2. What interval does f of -2 fall on? It falls on interval 2. Even though we see it in interval 1, is it equal? No, it's not equal until you're on interval 2. Does that make sense? Okay, it is here, but it's not equal until you're at -2. Okay, in the video, Dr. Khan mentioned that you cannot have it equal at 2 points. Otherwise, it's no longer a function. Does that make sense? Okay, all right, so we're going to use interval 2. So we're going to use function 2. And we have wherever their x is, we're going to plug in -2. What is -2 squared? 4. It's 4. So we have 1 minus 4. And what is 1 minus 4? What kind of 3? -3. So we now have f of negative. Now we know that f of -2 equals -3. Yes? Are we okay? All right. So at your table, you're going to evaluate f of 1 and f of 2. Do it first and then check with your peers. And then we're going to come back together. Okay? Got it? I'm going to give you 2 minutes. Okay, decide on what interval you're using. So decide on the interval. So what interval is 1 on? What interval is 2 on? And then you evaluate.
4 times 2.
Okay, let me watch. So -3. Do you know? So do you understand what that inequality is saying?
What do y'all get? Did you get for F1?
Okay, so that inequality is telling you your numbers can start at -3 and end at -2. That's it. Because it has a starting and an ending. And any number in between is on that interval. That's all that it's saying. So the second interval says I start at -2 and I end at 1. So any number between -2 and 1 is going to use the second equation. And then the third interval says I start at 1 and I end at 3, and any number between 1 and 3, I will use the 30.
Oh, no, hold on. If it's greater, if F two greater than
Is there a next?
I'm
I'm gonna walk away and let your peers see.
it's not number, it's not the dot. Because it has
No,
to
it's
be
you.
one up and up.
It's- the bracer is not-
It has to be greater than.
Wrong decimal.
I'm trying to, you're trying to remember this, she said, no,
Yeah, because it was not how the.
which one would I do? One, two, three. No, wait. It has to be greater than.
When we're looking at the sheet at F of negative, we find -3 that the equation is awesome, right? F of -2, we find the -2. and we use that equation. Therefore, after we find one, we use that equation, which would be.
Well, it's
X
one,
minus
but it's one minus x squared, so I'm gonna use zero to find the value.
We use that equation.
When I plug in, I get one.
If the one, if that.
But that's not
greater than
actually-
greater than
Yeah, now that they.
No, that's actually what interval you're using. I'm using interval two. See that is that function, one minus.
Wait, no, it's greater than greater
And now I can plug in what?
and greater than negative.
Was.
Plug in the one for the equation that you're using.
This question is where.
That's where you're plugging in.
This was the second one.
That's why I'm not plugging in X into all of them.
The.
Let's just
That's the one that's with number two.
That's supposed to be studied.
As long as it's the one.
Would that be because of
That's
this
because
one right there?
it's in the.
Yeah, one
it's
minus
well,
Is it because of that one right there?
And now
greater than
So, just do it, girl. It's simple, fast.
Number one.
All right, let's see where we're at. I think we're over our 2-minute mark. We're a minute and 20 seconds over our 2-minute mark. Yes, that's what I was saying. All right, here we go. So let's talk about our problems. So here it says, first, f of 1, we're determining what interval does it fall on. That means where is it included or equal at, right? So it's equal at interval 2, right? It's equal included in interval 2. It is the starting point of interval 3, but is it equal there? No, it is not equal or included on that interval. So you would use number 2. So I'm using this on my desk. Oh, no, in my pocket. Oh. You're welcome. All right, so we're gonna plug it in. So we have 1 minus 1 squared, which is 1 minus 1, which equals 0. The middle is my thought process, right? The middle is my thought process. I do not necessarily have to write that out. It's my thinking. Okay. Next, our next interval would be what? I'm looking for 2. I want to evaluate 2. What interval is 2 starting or stopping or on? Number 3, because 2 falls between 1 and 3, correct? So to evaluate this, I'm going to use number 3. So we have 2 to the third, and 2 times 2 times 2 is 8. So that's the value there. Okay. How do we feel about evaluating? Does it make more sense? Yes? We're good? Okay, because if we can't do this, then we can't graph, which is not good. The goal is to graph. Okay? Okay, so we can do this, right? Yes. Quickly. Okay? All right, here we go. Now we're gonna get to the main purpose is to be able to graph. All right, the steps to graph are acknowledging our breaking points / our boundaries. Your boundaries are where do you start and where do you end? What are your limits, right? Okay, I call those our breaking points because they're breaking our function into parts. Does that make sense? So in order to graph, the first thing we're gonna do is identify and plot our breaking points. Okay, our breaking points are where do our intervals start and stop. Our first breaking point is at -3 because that's where the first interval starts. So at -3, we're going to put a dashed line at -3. Agree? We're okay? Where does this interval end? At -2. So at -2, I'm going to have another dashed line. Okay. Our next interval is from -2 to 1. We already marked -2, but now we need to mark number 1. So we're going to go to 1 and we mark 1. Okay. Our next interval is from 1 to 3. We've already marked 1. Now we need to mark 3. These are my boundaries for my interval. These are the breaking points of my functions. Yes? Okay, step 1, easy. Step 2 is to evaluate. which is what we just practiced, right? Evaluating, but it's way easier because you don't have to do anything. You're just evaluating using your boundaries, okay? To know where you're marking them on the breaking point. So the first point that I'm evaluating is going to be -3, which we already practiced doing, right? So when we substitute -3 into equation 1 to function 1, what did we get? We got 5. So at 5, is it going to be an open or a closed circle? Closed. Why is it closed? It's equal to. Okay, my 3rd grade teacher, I went to Catherine Cook Elementary when we were the crocodiles. So she said, either your crocodile is hungry and has an empty tummy, or your crocodile is full because he had a Snicker bar. And that's how I remember. So this crocodile is full because he had a Snicker bar. Okay, this crocodile is going to be what? Hungry because he doesn't have a Snicker bar. All right. So at -3, 5. So I'm going to go to -3, go to 5, and I'm going to put a closed circle. -3, 5, closed circle. Now I'm going to do -2 because when you're evaluating your bounds. So I'm going to, if I substitute -2 in my head, I'm going to ask myself, Shauna, what is 2 minus -2? Shauna's going to tell me 4. I heard someone say 4. 2 minus -2. A negative times a negative makes a positive so it becomes 2 plus 2, which is 4. So I'm going to go to -2. At -2, is it an open or closed circle on 4? It is an open circle. Okay. Step 3 is to connect. If it's close, then you just connect them with a line and call it a day. Are these close to each other?
Yes.
Yeah, I connected. Close, like close together. And then 4, you're going to repeat steps 2 and 3 for your remaining intervals. Was that terrible?
No.
No. Let's do it again. So now we're on to our second piece. Our second piece is 1 minus x squared. We're going to plug in -2. We've already did this, right? Yeah. What did we get when we substituted in 1 minus -2 squared? We got 1 minus 4, and we ended up with -3. Is it going to be an open or closed circle?
Close.
It's going to be closed because our crocodile had a Snicker bar. So I'm going to go to -2, and I'm going to go down to -3, and I'm going to put a closed circle. Okay. Now I'm going to do 1. In my head, I'm going to substitute in 1. I'm going to ask myself, Shauna, what's 1 minus 1 squared? Oh, look, I've already did my brain work. 1 minus 1 squared is 0. So I go to 1. And is it going to be an open or closed circle?
Close.
Closed. My crocodile is full. Okay. This is an example of when they're not close, you have to keep evaluating. Are these points close to each other? No. Do I have any idea what's happening in between them? No. So I'm going to evaluate the other points. Okay. So my first point that I have to evaluate is -1. If I plug -1 in, what do I get? Well, a negative times a negative is a positive. And what's 1 minus 1? 0. So it's going to be a -1, 0. Okay, let's 1 minus -1 squared. What is that? 0. Have you been found? You say you were lost. Did we find you? Yes. All right, now we're going to do 0. So in my head, I'm asking myself, what is 1 minus 0 squared? What is 1 minus 0 squared?
0. I mean 1.
1. So 0, 1 is my next point. Do I have enough points to be able to connect them now? Yes. So now I'm going to follow my connected points. And there's the second piece of my function. Okay. The last one, we're going to do it again. So on our last piece, I'm going to plug in 1, but this time we have open circles. 1 cubed is what? 1. I have an open circle at 1. 3 cubed is 27, is gonna take me off the page. 2 cubed is 8. So I'm gonna go through 8 and then continue off the page. And that is our piecewise. Tomorrow, we're gonna do it again.
It's 1-1.
From start to finish, okay?
You make it go all